we are going to, let me move up the worksheet here a little bit. And again, the nice thing with the notes, you can use them on the quizzes. When's our next quiz going to be? Tuesday. Tuesday will be our next quiz. We are going to be working a little bit today with equations. Monday we'll do some review stuff. Tuesday we'll hit that quiz, and we'll just kind of keep barreling forward here. This itself isn't something new to us. We've been doing equations since the start of school. Now, though, we're starting to get them to be a little bit bigger. So, our key is right here. Make sure we get all of our x's together on one side first. And once we do it, it's pretty easy to work with. But again, it depends on where they are. For instance, this 2x and this 4x are on opposite sides of the equals. And we kind of look at that like a wall being there. If they're on opposite sides, we've got to do the opposite to get them where we want them. So, if I wanted to get this 2x over to the 4x side, what's the opposite? How do I undo a positive 2x?
What?
Subtract it. So whatever I do to one side, I do to both. So now we got all the x's together. So once I have all the x's together, what am I going to do now to get the 2x? But perfect. So finally what we would do is that divide by 2. Okay. So if they're on opposite sides, that's what I have to do. I have to do an opposite to get my x's together and kind of work it from there. However, what happens then if they're on the same side, like they are here? Because my equals is way over here. My ends are together as far as this goes. Yeah. Here, I'm going to combine the like terms. Now, I still got to watch out for my signs. And in this case, it's plus, so I'm going to go ahead and add them. But what I'm going to do instead is put them together, and now I'd solve it the way that I normally would. So I'd get rid of that minus 10 by plussing it. And sometimes, yeah, we're going to get a decimal answer, and that's okay. I don't even care if you do this and then you plug it in the calculator and it comes out a decimal, if you just leave it as the fraction. I'm okay with that. Now, if it did go in even, I'd hope you'd still get it to the right answer and simplify it, but this is actually a better way of going about it. So what we're going to do with this is we're going to go, okay, the only thing I really have to pay attention to as far as these go, and we're not going to do all of them because I want to give you as much time to be able to just work and get done as I can. But again, it comes down to where are the x's at for each one. If they're on opposite sides of my equals or my wall, I've got to do the opposite to get them together. So like here, it's a positive 2x. To undo it, I'll minus 2x. But that only happens when they're on opposite sides. Because then it's the stuff we've been rolling with for like weeks on end here. So basically after one step, this gets pretty easy. Undo my plus 7 by minusing it. And then just divide to finish it up. Now, are there some situations that can get a little bit trickier? Sure. Because you'll notice in every one of the ones we've done so far, we keep moving the x's to the left, to the left, to the left. Well, what happens in a situation like this? Because if I move this to the left, there's nothing left over here. So in a case like this, if you only have x's on one side, my suggestion would be to move the 2x back to this side. Now, you don't have to. I just think it makes it easier because now I just got my x's on one side and my numbers on the other. and I can get to my answer that way. And since 3 is kind of similar, we won't worry about that one for now. But again, take advantage of the area or the type of situation that you have with your equation. Just solve it that way. So let's see here. What else could we possibly get thrown our way here on the back that worries me? Oh yeah, I see a couple of issues. Okay. So for instance, another issue you could run into, let's say we jump down to number 8 for a second. If I jump down to 8, I want to get my x's together first. How could I do that? Subtract. And so I subtract 4x from each side, and I go, well, wait a minute. On this side, they cancel out, but they also cancel out on this side. There's no x's left. So when you get into a situation like this, excuse me, 1 of 2 answers is what you're going to get when all the variables disappear. Does negative 10 equal 8? No. If the 2 sides don't equal when all of your variables disappear, there's no answer that I can plug in for x that'll make it work. You just write no solution. Now, is that going to happen a lot? Nope. Now, I'm going to tweak number 9 a little bit because I want the 2 situations right next to each other. Let's turn this into plus 5. I'm going to run into the same situation with one small exception, though. If I try to get all my x's together, you're like, oops, they go away, oops, they go away. But the 2 sides do equal. That means every answer works. There's infinite solutions that work. And we can put infinite solutions, all reals, you know, something that works like that to get the language working. But again, those have all been ones that have been, you have variables on both sides of your equation. Now if I move it up a little bit, and I just want to do a couple down here and then I'll be done. If your x's again are on the same side, you're just going to put them together. So 4 plus 2 would be 6. And you're like, okay, once we get that done, this is just like it is on all of them. At that point, I want to get my x's alone, so I undo my minus 3. And then I just divide. Now, am I going to be adding those together every time? Not necessarily. For instance, if I'm looking at 10 and I'm looking at 11, I'm like, okay, they're similar in that they have their x terms on the same side of the equals, but when I go to put like terms together, I got to watch the signs. If I have 3 and I add negative 5 to it, I have a negative 2x. So combining like terms doesn't mean the number goes up in value every time. So I have to pay attention to my signs. And then again, I'm just going to do my opposite. So I can minus my 5 out of there. And then divide by negative 2. And again, I don't care if you get the decimal and you say, well, I'll just leave it as negative 9 over 2. Or if you plugged it in, you got the decimal and you want to write that down. I'm okay with either of those. That's no big deal to me. And that's how those are going to work. So again, if it's on opposite sides, we do the opposite to put them together. If they're on the same side, we go ahead and combine those like terms, but then it's the same after that. So, now, here's the nice thing about this. Because I knew some of you may need a little bit of time today to be able to work on the homework checks. So, the sheet that we've got here isn't for the current one that you have in your hand. It'll be for the next one. We're actually up to assignment 4 already on this one, so I'm trying to think. Did I write that down? I know, it's like we're just rolling. So this one, now here's the one thing though. The only part today you need to work on is the front. We will get to the back, but that's not going to be until Monday. with dealing with the distributed property. If you feel comfortable and you want to finish off the back to get ahead, you can. But this is the only side that you need to work on today besides working on any of the assignments from the homework check. And again, the bottom 3 here, I have extras of all of those over in the folders, but I also pinned them up there in case you're looking for them and going, now what one's this one? So that's basically what we're looking at for the rest of our time today, is getting this done, finishing the front of this, and if you want the challenge, go ahead and start working on the back of it. Because I didn't want you having a bunch of work to do on homecoming weekend. That's kind of ridiculous.